Hi, it's Jocelyn. So I'm about to do Evan Decode Day 6. Wish me luck. Alright, so we'll download our input, and it looks like it's just a single line of numbers, comma separated. Lanternfish, the seafloor is getting steeper. Maybe this lake he's got carried this way. So they must spawn to reach quickly to reach such large numbers, maybe exponentially. Okay. Each lanternfish creates a new lanternfish once every 7 days. It's not synchronized between every lanternship. One lanternship might have 2 days left until it creates another lanternfish, another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Alright. A new lanternfish would certainly need slightly longer before it's capable of producing more lanternfish, 2 or more days for its first cycle. Okay, so we have a lanternfish with an internal timer value of 3. After 1 day, its internal timer would be 2, and then 1, and then 0. Then after another day, it would reset to 6, and at the same time, so after 0, it would create a new lanternfish with an internal timer of 8. Why is that 8? 2 more days for its first cycle. Well, maybe we'll figure out soon. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. So it's after 0 that it resets. Realizing we're trying to do a submarine automatically produces a list of all the ages of several hundred nearby lanternfish. Okay. Oh, I see. It has a value of 8 because... oh no, where is 8 from? I am so confused. The list means that the first fish has an internal timer of 3, the second fish has an internal timer of 4, and so on until the fifth fish, which has an internal timer of 2. Simulating this fish over several days would proceed as follows. Okay, so we have all these decremented by 1. Oh, I see. So it resets to 6 because because they all eventually, we said that they all start, or they all create a new one every 7 days. Okay. And it's 8 because it's 2 additional for the first time. Okay, that makes sense. Alright, there we go. How many lanternfish would there be after 80 days? Okay, this makes sense. So we're actually splitting over commas, not new lines. So we can say let fish equals, or fish, which is a vec of numbers, equals it parsed and then collected. And we want this to be mutable just because we're going to add fish and stuff over there. So we also need to know, let's see. Okay, it's collect. There we go. So we're doing 80 days. So at the end, we're going to return the length of fish. Fish.length. So for 80 days, we're going to process each fish. Let's see. And that'll be the fish we're going to add that will all have 8. Okay. So we'll say that fish minus equals 1. If fish is equal to minus 1, then it will actually be set back to 6. And at the same time that it's set back to 6, we also add a new one. So fish to add dot push 8. Okay, this I definitely want to do a test for, so we're going to use just this example over here, and that should return 5934. Okay. Yeah, so this will be a U size, and this needs to be n mute fish to add. Okay, and it passed. So that is a little bit surprising to me, but I will take it. Let's see what we get. So we have an answer. And it's correct. All right, so going on to the second part. Suppose the lanternfish live forever and have unlimited food and space. We want to know how many there are after 256 days. So for the first one, there would be 80 days. And then we're going to do part B. And instead of 80, we're going to try 256. What are the chances this will just work? So it doesn't finish immediately. Let's see how fast this is going, just so we can get an idea. So if d mod 10 is equal to 0, then actually no, there's not too many days. We can just print the day. Okay, so it's starting pretty fast, and then it slows down. So how can we make this faster? So when we so we don't really need to process the same one like every time, or so we don't need to process every single fish every single time, but that can't possibly take too long, can it? Maybe there's some kind of pattern. I'm kind of worried about stopping this just because this is already at 170, but it's taking quite a long time now. Let's just look if there's a pattern. Oh, I don't really want to stop it though. I'm going to anyway though, because this probably won't get to 256 in a reasonable amount of time. Oh, there's also the question of like, so a given number is going to, any given number of fishes is going to produce a certain number of new fish after 256 days. So we could try to solve it that way, like solve each number and then add them together. Yeah, I like that. So let's try that. What should we call this? From fish. Okay, no, we're going to call this, yeah, num fishes. And so it will take, it's going to take a number of, yeah, like the state as in I64 and number of days. And I'm just going to solve this naively the first time. And then after that, we're going to see if we can, we're going to see if we can improve it. So just super naively, or we can say that fish equals just a vec with the state. Okay, and then we can memoize this if we need to. I'm just curious how much faster this one will be, just a really stupid solution. So we'll say count equals 0, and for fish in fish, we're going to say count plus equals, or like, yeah, so we'll say count from fish equals num fishes, fish in days, and we're going to have a hash map. Otherwise, we're just going to add it. So insert fish count from fish, and then same thing again. And then probably can improve this afterwards, but let's see what this does. So this will just print every time we're done one fish. We just need to get to 10 of them. So, it's not getting done with any of the part B ones, I guess. So the logic isn't broken. Okay. So now I guess that means we need to memorize this more aggressively. So this would be a hash map from the question, which is the state and the number of days, and it maps to a usize. So here, instead of doing fish to add.push 8, what we're going to do is we're going to compute a count, which starts at 1, just from the one fish we're considering. And then we're going to say count plus equals num fishes. So this is the new state, which is 8. It's the number of days remaining. And we're going to pass our memo in as well. And here we're just considering one fish. All right, and then here we'll say memo.insert. So we have, let's see, ridge state and the number of days, and that goes to count. And then here we're just going to check to see if there already is a result. So if let's result equals memo.get ridge state days, then we'll just return that result. And this needs an ampersand. Let's see, we need our memo. And we'll probably get rid of known because it's, you know, the same. And we got rid of fish to add, instead we're doing count there. Okay, and we got an answer, and I'm just going to test this right away. So you see we have an answer. That's a lot of lanternfish. That's not the right answer, darn it. Okay, so let's see if we broke our example, first of all, just with 80. I'm wondering if like days is off by 1 here or something. Okay, yeah, days is just off by 1. It doesn't reproduce on that specific day. It reproduces on the next day. All right, and now we have a different answer, which is still really big. 14 seconds, okay. That gives us some time to try the other example, or that's actually 14 seconds. 3 more seconds. And 1 gold star, okay. So this wasn't a great day, but you did get it. So thanks for watching, and I'll see you tomorrow.